Hello guys, welcome back to my channel. Mason African Motives, still working on O-level mathematics. So if you have to cross-check, we are having the question paper which was actually written in November 2018, and we managed to work with the paper 2 part, if I'm not really mistaken there, but I think we managed to work on that one. So we shall actually focus on this paper. As you know guys, our instructions and everything, the information that should be given is very important for you. So we shall quickly rush through the questions, and also take notice paper 1, neither mathematical tables, no slide rules, no calculators may be used in this paper, which means these are actually not allowed to be part of your exam. Okay, so the first question is to simplify 2 to the exponent of 3 over 5. This is 5 to the exponent of 2. I don't know if it is much clear, but here is just simplifying. We know that 2 to the power of 3 is going to give us 8. That is 2 times 2 times 2, 3 times, okay, which is going to give us 8 over 5 to the exponent of 2, which is 5 times 5, and this is just 25. Okay, so as you can see guys, this was just a direct answer, 8 over 25, like that. Okay, on B item 1, we are asked to express 6 over 25 as a decimal fraction. So definitely we have to divide 6 into 25 into 6, that will be a 0 comma, we have to add, or we have to put a 0 there. Now is 25 into 60. Definitely we are going to work with 50 there, which is going to be 2 times into 50, so 60 minus 50, which is going to give us a difference of 10. Okay, 60 minus 50, which is a difference of 10. But we know that you are going to put a 0 again to that difference. This is a difference of 10 that you obtained, then we put a 0 there. So it's now 25 into 100, which is going to be 4. So you don't put another comma, no, you just use the comma that already you are having. All right, then 0,125 in standard form. So definitely in standard form, you have to move 1 comma to the right, which is going to be 1,25. Now it's between 1 and 10. Remember, the major issue is to make this number to be between 1 and 10, but times 10 to the exponent of minus 1. Why? We started with a 0 digit, so it's going to be a negative. If it is a whole number, then it becomes a positive, like maybe it was 12,5. It's a whole number, so it becomes a positive. Okay, then on number 2 guys, we're just given from the list of the numbers that we're given, can we choose a square number there? So remember, a square number is the one that we can obtain the square root of that number. It's an exact value, the square root of that number. All right, so as we can see guys, square root of 3 over 7, we do not have anything. But if we cross check square root of 121, we know that square root of 121 in this case gives us 11. So which means we've got a perfect square. This 121 is actually a perfect square, so we've got 121. All right, but some might ask about this value here. No, this value, when you are given it as square root of 64, the number that you are given here is not 64. You are given the square root of this number, which we know that square root of 64 is plus or minus 8. So this is the number that is written here, but they just wrote it as square root of 64. So this is not a perfect square. Okay, so don't be confused with the square root of 64, because it's plus or minus 8. And if we find the square root of 8, it's not a perfect square, because a square is supposed to give us a whole number. Okay, then we move on to B, which is the irrational numbers. Remember, irrational numbers, these are the numbers that are not exact. When they are expressed as decimals, they do not end. They are not exact. Like 3 over 7, guys, if you divide this decimal is not, we do not need a calculator. Just looking at these values, 3 and 7, they've got nothing in common. So we've got 3 over 7 here. We move on to another one, 11. That one, it's an exact value, because it's just like 11. There's nothing, it's just a whole number, so there's nothing here. Square root of 3 over 2, it simply means we have got square root of 1,5, and this, we can't find this square root, so which means it's also part of irrational numbers, because square root of 3 over 2 is going to give us an endless decimal. That is an irrational number. Okay, minus 19 is already in exact form because you can't do anything. Pi, okay, pi, I told you guys on introduction of says that pi is an irrational number. Remember, you are talking of a constant like 22 over 7, or you see that it's an endless decimal. Then square root of 64, remember square root of 64 gave us plus or minus 8, which is an exact value. So this one is not an irrational number, it's a rational number. So these are the irrational numbers that we had. All right, then on 3a we are to express this number as a number in base 5. Okay guys, you can convert this number to base 10. Yes, it's fine, you can do that. Then you divide by 5 throughout, but this was a conversion which was done on a number which was being converted from base 5. This is a conversion which was done. Number can be, let's say, 5 times 10 to the exponent of 3 plus 3 times 5 to the exponent of 2 plus 2, like that. All right, so if we are to cross check on this number here, we are going to see that this was a conversion that was actually taking place from base 5 going to base of what? To base of 10. So we can actually rewrite this number in a normal format that we know is supposed to happen, because if it was so that we are converting from base 5 to base 10, which means we're supposed to write this in terms of what? Powers of 5, as we can see, to the exponent of 3 to the exponent of 2, which means we are supposed to have 5 to the exponent of 1, 5 to the exponent of 0. All right, so let us just rewrite this. It's going to be 4 times 5 to the exponent of 3 plus 3 times 5 to the exponent of 2. All right, this part is fine, but we do not see any part that has got 5 to the exponent of 1. And we know that 5 to the exponent of 1 is going to give us what? Is going to give us 5. We are in base of 5, and this is going to give us 5. But here we are not seeing anything that has to do with 5. The only number that we see is 2. So which means this number was actually multiplied by what? By a 0. That is why it's not totally represented. So you're going to represent this as 0 times 5 to the power of 1. Now it's there. So that what we need is to know the number that is multiplying 5. All right. We move on to this 2. We know that this one was supposed to be 5 to the exponent of 0. And we know that 5 to the exponent of 0 is 1. Any number to the exponent of 0 is what? It's 1. And the number that we multiply now to give us 2, it means it was definitely written like this. 2 times 5 to the exponent of 0, like that. So this is another method. That is why I'm explaining this, because previously I used to explain another method of just converting to base 10, then you convert to base 5. But now I want you to understand this method here. It can be easier if you know what is actually happening. So if you can cross check, this is a format that you do when you are converting from base 5. Remember, you raise to the export to the basis of 5, which is 5 to the exponent of 0 to the exponent of 1 to the exponent of 2 to the exponent of 3, which means this is representing what? This is representing your base. And these are the numbers which are in that base, which is in base 5. And they want us to give this number in base 5. So which means these are the numbers in base 5, which is 4, 3. Here we've got a 0, and here we've got a 2. In base of what? In base of 5. So we can obtain our answer in a direct or in a simpler manner like that. So like I said, guys, you can convert this to base 10, expand everything, then divide by 5 throughout. You're going to obtain the same value as this one. So I want you to try it and see if you're going to obtain the same answer. If not, then that means you have to redo that one until we obtain the exact thing. Okay, they were asked to simplify or to evaluate, give you answer in base 2. Already these numbers, they are in base 2. So what you just need is to write them in a proper way. Okay, so the first number is 1, 0, and these are 3 values there. So it's 1, 0, 1, 1, 1, base 2. So I'm going to add this way. So take note here, I've got 4 values. So I'm going to start from the far right going to the left. So it's 0 1 0 1 going to the left. So that's 0 1 0 1. So that these numbers, they are in line from the right side going to the left. All right, so we can add. Remember, we are in base 2, guys. What we do not want in base 2 is to see any value that is equal to 2 or that is more than 2. That is what we do not want to see. All right, so let's add 1 plus 1. That's a 1. It's less than 2, so we can just write our answer as it is in base 2. But if we move on here, 1 plus 1, it is giving us 2, which is equivalent to 2, and we do not want to see anything that is equal to 2 or anything that is greater than 2. So now how are we going to go about it? Remember, divide by the base. 1 remainder 0, 2 into 1, that's 1 remainder 0. So you write your remainder here on your answer, then this one you're going to add to the following number there, which is 1. So it's 1 plus 1 now plus 0, which is again 2. So as you can see, guys, we are back to the same 2, which you said 2 divided by 2, 1 remainder 0. So it's 0 here. We give here another 1. So we add again 1 plus 0 plus 1, 2 again, which is 1 remainder 0. Again here we give 1 plus 1, which is 2. We do the same, 1 remainder 0. You write your remainder, you give 1. As you can see, now you are adding to 0, so it's like 1 plus 0, which is what? Which is 1. So what is important is that the number should be less than the base. So as long it is more than the base, divide by the base, not the remainder. You write your remainder on the answer there. All right, anyways, let's see the other part, which is to subtract. Okay, this is actually base 7, so don't mind how it is written there. That is base 7. So let me put it the way it's supposed to be. Like it's supposed to be like this. 5 1 2 in base 7 is first one, minus 4 3 5. So as you can see, these numbers, they're actually 3 digits, so you can just write them in line. These ones, they are fine in base of 7. Okay, so we are subtracting, guys. This time we are subtracting, so you're just going to do the same thing. 2 minus 5, which is impossible. So what you're going to do, we have to add the base. So if we add the base here, now this time you add the base. When it is impossible for you to subtract, you add the base. So it's 7 plus 2, which is 9. Then you give 1 here, which is now 4. So 9 minus 5, which is now 4 in base of what? In base of 7. All right, we move on again. 1 minus 4, that's impossible. We have to add the base. So if we add the base here, that's 1 plus 7, which is 8. The moment you add the base here, you're going to give 1, which is now 5. So it's 8 minus 4, which is 4 in base of 7, because 5 minus 5, that's a 0. So you're going to obtain 4 in base of 7. Express 0045 in 12-hour notation. So this is a time which is in 24-hour notation. 0045, which is actually in the morning. So it's going to be 12:45 a.m. So that's what you're going to have there. Take note, guys, you represent with 1 dot here, a single dot. All right, then we are given that there's a Gotha's local time is 3 hours 45 minutes ahead of Harare local time. So we are given a time frame that is 3 hours ahead of Harare. Find the time in Harare when the time in Gotha is 23 hours. This is a time in 24-hour notation. So this is what is happening, guys. We are saying this particular place that we have, it is 3 hours ahead, which means if we are to talk of Harare from that sit now, which is Gotha's local time, it is going to be 3 hours 45 behind, because this one is ahead, which means this is behind. So which means Harare is actually 3 hours 45 minutes behind, opposite of what is happening. That one is ahead, so which means Harare is what is behind. Why are we referring in terms of Harare? Because we are given to find the time in Harare, while least we are given the time in Gotha's place. So we have to express Harare in terms of this time. That is why we have to express it in terms of the time in order to say it is behind. So behind, which means we have to subtract from this local time, which is 23. So this is 23 hours minus 3 hours, because it's behind, minus 3 hours 45 minutes. So if we subtract this, as you can see guys, it's going to be impossible for us to subtract 63 minus 23 minus 45. So we're going to borrow here 1 hour from 21, which means we are going to be left at 20 here. If we add 1 hour here, these are minutes, so we are going to add 60 minutes, and which means we are going to be at 83. Okay, this was at 23, so it's going to be 83. 60 plus this one, which is 83. So guys, you can subtract 83 minus 45. This is normal subtraction, which is going to give you 38. 20 minus 3, which is going to give you 17. So which means in Harare the time is 17:38 hours in a 24-hour notation. If you want to write it in 12-hour notation, it's going to be 5:38 p.m. like that. So that is if you want to write it in what, in another notation, but here we can just write as it is. So that is what we had guys on item B. Then on item C, we're asked to convert 5 square kilometers to hectares. Okay, that's what we have on C. How can we convert square kilometers to hectares? Okay, we must have a relationship of something that we actually know about. Like what I'm trying to say is that we know a relationship between square meters and hectares. That is what we know. This relationship, we know it that in a square, in a hectare, actually we are having 10,000 square meters. That is the relationship that we know. When it's now square meters, it's going to be difficult for us. So what can we do? We can simply convert this, because we also know we have got a great relationship between square meters, square kilometers, and square meters. What is the relationship between these two? If you do not know this relationship, then start from the basics. What are these basics? 1 kilometer gives us 1,000 meters. That is what everyone knows. In a kilometer, we've got 1,000 meters. So these are square kilometers. So in order for us to have square units, we have to square both sides, which means 1 square kilometer is equivalent to 1,000 squared, which is 1 million square meters. So if you do not know this by head, then you can take it from where it was constructed or where it was generated from on this part. Now, if we know that in a kilometer we've got 1 million square meters, therefore, what about these 5 square kilometers? How many meters? Because we want to have it in terms of square meters so that we can convert to hectares, because it's a relationship between hectares and meters. So we have to convert this first to what? To square meters, so that it can be easier to put to square meters. So we are saying 5 square kilometer is equivalent to how many? As you can see, it's just multiplying 5 times 1 million, which is 5 million square meters. So 5 square kilometers is equivalent to 5 million square meters. So therefore, how many hectares are equivalent to? Because it's now easier. Square meters can be to hectares, so square meters can be also to hectares. So using simple proportion, guys, as you can see, it's going to be 5 million over 10,000 multiplied by a hectare. It's now in hectares, because these are square meters, they cancel. So 3 zeros here, 3 zeros here, 1, 1, 4 zeros actually, which is going to be 500 hectares. So that is what you're going to have. So if you know these by head, it's not going to take us much time, but now I'm just explaining so that all of us might be part of the class. Anyways, let's see this part, which is to express in ordinary form. You are given on 5a item 1, which is 6 this is 6,07 times 10 to the exponent of 4. So in ordinary form, guys, as we know that if you have to express in ordinary form, this is to the exponent of 10. So you simply multiply by 10,000, or you can just move as comma, as you know that if you're multiplying by a positive number, you can move your commas to the right, 4 commas to the right. So that's 1, 2, 3, 4. So in each and every groove you have to put a 0 there. In each and every groove you have to put a 0 here, a 0 here. So your answer is going to be 60700. This is comma, we don't know, comma 0000. So all those comma 00 after the comma, they are not important. So that's what we have there. Then on B, we are asked to evaluate these numbers, giving your answer in standard form. Alright, so whenever you are adding numbers in a standard form, remember guys, I told you that we have got so many ways that we can use, but the easiest way that cannot make you have mistakes is to just convert the given numbers that you have in ordinary form. It's gonna be very easier. Then you add, because you are used to add numbers in ordinary form. So just convert the given numbers to ordinary form, then you can add them. So how do you convert to ordinary form, guys? This is times 10 to the exponent of 1. So you move 1 comma to the right. So it's going to be 25 comma 3 plus, this is to the exponent of -1, just move 1 comma to the left, negative, you move comma to the left, which is 0.61, just like that. You can apply those concept of 6 comma 1 times 10 to the exponent of 1, which is over 10 to the exponent, which is, it's fine, you can do those. But when you are given an exponent with base of 10, just move the comma, the number of the exponent, which is the positive, to the right, negative to the left, just like that. So when these numbers are in ordinary form like this, it's going to be easier for us to add, because we've got 25 comma 3, which is now added to 0.61. Make sure the commas, they are in line. All right, so this is going to be a placeholder there. So if you add, you're going to have 1 and comma here, 3 plus 6, which is 9, 5 plus 0, which is 5, and 2 is going to be 25.91. So this one, guys, we just add properly. This is a number in ordinary form, but we are given to express our answers in in standard form. So how can we express in standard form? We have to move 1 comma to there, which is going to be 2.591. We just moved 1 comma, and the number was, it's, when you are converting, it's not that I'm moving to the left, so it's going to be negative. No, that one, you move a negative when converting, but when expressing to standard form, you ask yourself to say, the number that you have, it had a significant digit, which is a whole number here. So my exponent, or my power, is going to be a positive exponent. Okay, that is the concept that you have. So that's the easiest way that you can do, guys, to just convert your numbers. Yes, you can do other ways of factorization, which, yes, it's fine, but most of us, guys, we end up making a lot of mistakes there, but it's still fine. Then we are given a diagram where we have got parallel lines. So in this case, it's easier for us to just list or to fill in our information. This is angle APR, which is 84, RQS, which is 90. So this angle is 90 degrees here. And also take note that these lines, they are equal. All right, so there are so many ways that we can do, guys. What can we have? Remember, we can find angle at P. This angle, we can find it, this angle here, and this angle here, they are equal. Remember, opposite, from the opposite concept, this side and this angle, this side and this angle, they're equal, because these two, they're equal, because this one is an isosceles triangle. Also, the concept of alternate angles, we have to apply everything. Okay, so the first question is to calculate angle PRQ. That is our first question, PRQ, which is PRQ, this angle here. Okay, there are so many ways to find this angle PRQ. We can actually find this angle at P, so that we can subtract that from 180, so that we can, this one, angle P. It's another way, 180 minus 84, all right, which is going to give us 96. So which means the angle at P there is going to give us 96 degrees if you subtract properly in this case. So we are going to obtain 96. All right, now in this case we've got 96 degrees, which is here. All right, which is this case here. This is your 96, and we say these two, they are equal. So definitely to obtain each of these two, I'm going to subtract this one from 180, then divide by 2. So it's simply 180 minus 96 divided by what? By 2. So the moment you divide, you subtract these two, you're going back to this 84, which is 84 divided by what? By 2, and you obtain 42 degrees. So most of us guys, that is how you simplify this question, by doing, which is going to be like you've involved a lot of things and a lot of repetitions here. So how can I actually avoid all these repetitions? Okay, this is the case. This is an exterior angle here. These two are the opposite interior angles. So the sum of these two angles, the interior opposite angles, it must give you the exterior angle for a triangle. So this angle of 84 is supposed to be equal to the sum of these two angles. So since we did not know these values, we just say this is x and also this must be x. So this is how we're supposed to do it in another way. So you just add x plus x, which is 2x, is going to give us 84. Why choosing x and x? Because they are equal. So if I put y here, this must be y also. So that's it. So divide by 2 by 2. That means our x is going to be 42 degrees. So that's how easier you could have done it. So I don't know how you see it. Anyways, let's move on to QRB. So QRB, that is Q R to B. We are now referring to this whole angle. Let me maybe indicate this way. That is QRB, this angle here. This is the angle that we are talking about here. All right. So to find QRB, we see that we can actually have this angle here, like this. Okay, remember these are parallel lines. Okay, these are parallel lines. So this angle here, QRB, this angle, the whole of this angle, and this angle here, 42, the one that we said this one and this one, they are equal. These two, they must give us 180 degrees. Why? We are talking of co-interior angles. They add up to 180. So to find QRB, definitely I'm going to subtract this angle from 180. So my QRB is going to be 180 minus 42. That's it. So 180 minus 42, which is going to give us 138 degrees. So that's my QRB, just like that. We are having alternate angles which are given us. So there are so many ways you can use this concept to find this angle PRB, then you add it to 42. So if you do that, still you apply the same thing. These are co-interior angles. So 180 minus 84, this is 96 degrees. 96 plus 42, you must obtain the same answer. All right. QSR, okay, this is QSR, which is QSR. All right, so let's see where we have our QSR. QSR, this angle here is the one that you want to calculate. Okay, so how can we have this angle QSR? So there are so many ways again that we can use here. If we are to cross check here, we said this is actually 42. This angle here, if we are to consider this z here, you're obtaining a z here, which is you're talking of alternate angles. So this angle and this angle, they are equal, which is SQ going to this point at which is on the other hand. These two, they are equal. All right. So if these two angles, they are equal, how can we determine this? Because this one we can simply find it because we are talking about angles on a straight line where we have got 42 degrees and 90 degrees. So to find this remaining angle is going to be 180 minus, you add the two, 90 degrees plus 42 degrees, which is going to be 180 minus 132 degrees. This is going to be 132 degrees, which gives us 48 degrees. So this is going to give us 48 degrees. As this is 48 degrees, this is also 48 degrees. So that's the concept. So guys, as you can see, that is how these questions they just ask. So it's this 48. So there are so many ways, but you must obtain the same answer as this one. So you can try to do other ways. Make sure that your answer is just in line with the ones that we are having. That is what is very, very important. Okay, on number 7, we are given to solve the simultaneous equations. So how can we solve these simultaneous equations, guys? So many ways that we can actually apply or do working with a substitution, elimination by substitution. So there are so many ways. So but what is important is that your answer and this must be the same. So in this case, I can choose to apply elimination. I can eliminate this part if they are the same, so which means I can just multiply here by 3. You just interchange these two numbers. All right, so on top I'm going to multiply by 3, bottom I'm going to multiply by 2. So 3 is multiplying everything on top. 3 times 2, which is 6x, 3 times 3, which is 9y, 3 times 11, which is 33. You multiply every term, okay? Then 2 multiplies also every term, so it's 2 and 3, which is 6x, 2 and minus 5, which is going to give us minus 10y, which is equivalent to 2, and minus 12, which is minus 24. So that's what you're going to have. Then definitely, as you can see, x and x here, they are the same. So how can we eliminate this? Subtract. So you can subtract equation 2 from equation 1. So 6 minus 6, that's a 0 there. 9 minus 10. So this is minus, which is a plus. So it's going to be 9y plus 10y, guys, which is going to give us 19y in this case. The same here is 33 minus, so it's going to give us a plus, which is 33 plus 24, which is going to give us 57. All right, so that's it, guys. So as you can see, divide by 19 into 57. This is what? This is 3. So y is equal to 3. So to find x, definitely I have to substitute into any one of the equations. So maybe let me just take the first one. 2x plus 3y in this case is equivalent to 11. And we have got our y, which is 3. So you can substitute here in place of y, which is 3. So 2x plus 3 times 3, that is 9, is equal to 11. Then we can transpose 9 to the other hand, is going to be 9, which is minus 9 here. So 9 from 11, that is 11 minus 9, which is 2, divided by 2 both sides, by 2 both sides. So your x is going to be 1. So these are the values that we are having. So therefore x is equal to 1 and y is equal to 3. So that's how you simply find. So there are so many ways actually to find these unknowns. So you can't say this is the only way that we have. There are so many ways. So just try and work out those ways and see if you're obtaining the same thing. Then here we are given that the wavelength W here is inversely proportional. So this is 1 over inversely proportional to its frequency, which is f. All right. W, when f is equal to 90 and w is equal to 675, find an equation connecting f and w, which means in order for us to have the equation which connects these two, we must introduce a constant. Take note, it's the wavelength w which is inversely proportional, which is 1 over. So we must introduce a constant here, which is w is equal to k over f. So we have to find the value of k first, so that we can write the equation. So how can we find the value of k? We are given f is equivalent to 50 when w is equal to 675. So w here is 675, which is equal to k over f. Our f is 90, like that. All right. So that's it. You just cross multiply. I think it's clear, guys. Here just cross multiply so that we can have the value of k. So k times 1, that's k is equal to 90 times 675, and this is going to give us 60,750, guys, if we multiply properly. This is no more multiplication, as we know, guys. So that's our k. So therefore we can write this as w is equivalent to k over f, which is this value of k, 60750 over f. So make sure that you multiply properly. You're supposed to obtain this value there. So that's the equation which connects the two. Then find the value of f given that w is what? W is 500. So it's simply a matter of substituting here. In place of w, we substitute 500 is equal to 60,750 over f. So we want to calculate f. We can cross multiply again. Okay, that's 500 times f, which is 500f is equal to 1 times this value, which is 60750. So to find f, definitely guys, I have to divide by 500 by 500 both sides. So that's our f here, which is going to give us this will cancel. So then we have to reduce, guys, until we obtain an exact value. I don't know, let's maybe try by 5, which is going to be 10 here. By 5 into 6, that's 1, remainder 1 here, into 10, that is 2. Then that is 2 here. 5 into 7, which is 1, remainder 2, into 25, which is 5. Since you are dividing by 10 here, because you are now left, so this simply means you just have to move 1 comma here. So that is going to be comma, like we've got 1 2 1 5 like this. So you just divide by 10, you're just moving 1 comma like that. So it's going to be 121 comma 5. Just like, guys, you have got 3 over 10. It's just same as moving 1 comma like this, which is 0 comma 3. So it's just same. You can take advantage of that because you've got 10. So it's paper 1, guys. You do not have a calculator, so sometimes you have also to take advantage of some of the questions, because otherwise you work a lot of things. Okay, we are given to write the number that you are given, which is on number 9a. We are given 9, this is 45,3981. That's the number that you're given, and you're asked to write this correct to 4 significant figures, that is for SF. So remember, significant figures, these are the whole numbers. So you're going to count 1 2 3 4. So to for SF, there's a number which is follows, which is 8, and this 8 is going to affect this 9 into 10, and it gives 1 here, which is going to be 4. So it's going to be 45,40 there. So that is what we have. Then a student spends 8 seconds correct to the nearest second to solve a problem. Then you're asked to find the limits between which the time lies. Take note the time frame, how it is given, where A and B are the constants and T is the time. So we are given that there is a time that was rounded off to the nearest whole number in this case, which is the time that we are given as 8 seconds. All right. So now we are given to write these limits in terms. Take note how the limits are given. This was rounded to the nearest whole number. So if it was rounded to the nearest whole number, that means we have got 2 conditions of having a decimal from this 8 that we have, which is we just subtract. I told you guys, you subtract 1, which is going to be 7,5, which is the maximum value, but 7,5. 2, the maximum value, you maintain this 8 as it is, but now it will be 4, so that when you round off this, it becomes 8. If you round off, it becomes 8 again, because 5 is going to change this, 7 into 8, 4 is going to change this, is not going to change anything, I mean. So these are the limits. But because of the presentation here that we are given, that is greater than or equal, which means this one is part of our answer, because greater or equal to. So T is greater or equal to 7,5, but less than. This value is not involved because it's less than or equal to. So we are going to take 8,5 in this case, sorry. That is what is going to happen. So that's how you simply represent this. Maybe if it was a condition like they have given you to say T is greater than or equal to A, less or equal to B, therefore you're going to take this as it is. T is greater or equal, because they are part of your solution, so they must be what? Included. All right, so in this case you are not going, because we are given less than B. All right. Alright, so on question 10 there we have 10a, which is to factorize completely. This is actually 3x squared minus 15x. So how can we factorize such type of an expression, 3x squared minus 15x? So as you can see, guys, it's a matter of checking because we've got two terms. So 3 is common between these terms, and also x is common because you have to factor out the highest common factor. So we've got 3x here as our highest common factor. So we divide 3x squared, divide by 3x, 3 and 3 will cancel, x squared and x, we are going to have x minus 15x and minus 3x, which is going to give us minus 5. So this one is direct, guys. Then on number B, 10b, we are now asked to find the highest common factor, which is the HCF of these three terms. So what you're going to do is to just expand these numbers as product of their prime factors, then everything is going to remain like that. Okay, so let's just expand. The first number is 8. So as a product of its prime factors, we've got 8 divided by 2, which is 4, 2 again, which is 2 into 2, that is 1. So that means 8, this, now we are now taking this expression, KL squared M, KL squared M is equal to 2 times 2 times 2, so this will be 2 times 2 times 2 times, this one you just write as it is. All right, so these ones just write as they are, don't worry about them. Okay, we have got 28. So if you do the same for 28, guys, as a product of its prime factors, 28 is going to give us 2, which is 14, 2, which is 7, 7, 7, that is 1. So we are going to have 14, sorry, that is 28 here, 28 squared L cubed M. So this is k squared L cubed M, which is going to give us 2 times 2 times 7 times k squared times L to the exponent of 3 times M. All right, we'll move on to 36. So guys, just do the same. 36 L squared Mn is going to give us that's 2 times 2 times 3 times 3. So this is what you're supposed to get. Make sure that you divide properly, guys, just like what we did on these ones. Then you've got L squared times M times N. All right, so that's what we have. So remember, here we are supposed to have to obtain the HCF, which is the highest common factor, and I told you guys that the highest common factor is common throughout. So talking of these numbers, we've got 2, 2 and 2 is common throughout. We have got 2 again, which is common throughout. All right, as we can see on these numbers, we no longer have any number that is common on these numbers. All right, we are done. We move on to the letters. K is not common. We have got K here, K, but here we do not have K, so it's not common. L is common. We've got L, we've got L, we've got L here. But how are we going to write this? For HCF, you're going to take the one with the smallest exponent. When it is common like this, you take the one with the smallest exponent, which is this one, L squared, or this one. So you're going to take L squared, the one with the smallest power, the smallest exponent. All right, we move on to M. M is common. We've got M, and it's just the same because it's M to the exponent of 1, which is just M, and N is not common, so we're not going to take this part. All right, so that is 2 times 2, which is 4 L squared M. So just like that, that's your HCF. That's what we had in this part. So on number 11, we are given that there are points which are on a straight line, which is A and B. Then you are given to calculate or to find the gradient. Remember that the gradient of a line is equal to M, which is equal to y2 minus y1 over x2 minus x1. So what you simply need is to name your points x1, y1, x2, y2. That's it. So we are going to have y2, which is 5, minus y1 here, which is 2, over, that's x2 minus x1, which is x2 here minus x1. So it's 8 minus 6. So simplifying properly, guys, 5 minus 2 is going to give us 3. Okay, that's 3. And 8 minus 6, which is 2, so that's 3 over 2. You can maybe write it as 1.5, or you can leave it like that. For gradient, it's fine. All right, then we are given to find the equation of line AB, giving your answer in the form. So this is the format that we are given to write our answer, in the form of y is equal to mx plus c. All right, so remember, guys, I told you on a straight line that if you are given y is equal to mx plus c, m represents the gradient, and we calculated this m, which is the gradient, and we said is 3 over 2. So we are going to substitute in place of m, that's y is equal to 3 over 2x. So what you need now is to find the value of x. So you're not supposed to worry about this value of c, I mean, because you have the value of y and the value of x from these 2 points that you are given. You're going to substitute, or you're going to take 1 point there. All right, so in this case, I'm going to just use the point A, which is 6, 2. So this is your x, and this is your y there. So in place of y, we are going to substitute 2, which is equal to 3 over 2 times x, which is x is 6 plus c. So that's it. So in this case, we are going to simplify 2 into 6, that is 3. 3 times 3, which is 9. So 2 is equal to 9 plus c. Transpose to this side is 2 minus 9, which is equal to c, and c is going to be minus 7. That's 9 minus 2, guys, which is 7. It's going to be a negative. So you have the value of c, so you have to substitute here, because we had to calculate that value of c. So now we have it, so let us substitute. So therefore y is equal to 3 over 2x plus c, but our c it's a minus, so plus and minus is a minus, so it's going to be like this. So that is our equation. So there are so many ways, guys. We can use the other way of finding the equation of a straight line, where you have y minus y1 over x minus x1 is equal to the gradient, then you work from there. So you see that you have got so many concepts that you can actually apply, as long you apply the right thing. All right, number 12, we are given to simplify, that is to simplify the given fractions. All right, so as usual, guys, for fractions, it is best for you to first factorize, then you can simplify as much as you can. So that is 2a plus 6 everything over a minus 3, which is being divided to a plus 3 everything over a squared minus 2a minus 3. So for you not to make mistakes, it's best for you guys to introduce multiplication sign, then you do your factorization afterwards. So let us introduce multiplication. So remember, the moment you introduce multiplication, you are going to invert the second fraction, that is interchange. So it's going to be a squared minus 2a minus 3 over a plus 3. So working with the expressions, you're supposed to know the type of expression that you are working with. You are working here with a linear expression, so you can factor out 2, which is common. So 2a divided by 2, that is a, plus 6 divided by 2, which is 3. Everything over a minus 3, there's nothing that I can do on this part, so just leave it like that. Maybe you can just open a bracket, it's fine. Then here we've got a squared minus 2a minus 3. Remember, guys, I told you that when you are factorizing a quadratic expression and the coefficient is 1 like that, you can factorize this in an easier way. Okay, this a plus 3 does not change. Let's just write it. So you just write a here, okay? Then you focus with this term, which is minus 3. What are the factors of minus 3 that when you add, they are going to give you minus 2? Factors of minus 3, we are talking of minus 3 and 1. Minus 3 times 1, that is minus 3. Minus 3 plus 1, that is minus 2. So you've got a minus 3, a plus 1. So you just write these numbers as they are in the bracket, because the coefficient of a squared is 1. It only happens when the coefficient of the first term, which is a squared term, whether it's x squared, it's y squared, when it is 1. When it is not 1, then you have to do the longer way of factorization, or you can even do the longer way here. Still, you're going to obtain the same brackets. All right, so guys, let's cancel this one, and this one can cancel. A minus 3, A minus 3. So that's what we have, as long it is between the numerator and the denominator. So you're going to be left with 2 into A plus 1 in the numerator, because it's like 2 into A plus 1 like this over 1. And anything over 1 remains as it is, like 3 over 1. We know that 1 is 3, so that's the same even with the what? Even with the expressions that you'll be given. So that's it, guys. Let's see another question that we had, which is number 13. Yeah, that's number 13. Where did I put this? Okay. We are given on number 13a to express the ratio of 3,5 kgs as to 800 grams in its simplest form. So whenever you're given a ratio is just like how you operate with a fraction, just like how you operate with a fraction. All right, so this is 3,5 kgs as to 800 grams. That's what you're given, but you must be very, very careful with the units that you're given. Are they in are they corresponding? Like, are you given grams and grams or kgs and kgs? Because you can't divide kgs and grams, so we must convert to the same unit. So I'm going to utilize the gram because it's easier for us. Just multiply by 1000, because we know that in a kg we have got 1000, so it's going to give us 3,500 grams as to 800. So this is now in grams, and this is now in grams. So we can reduce just like how you operate with a fraction. That is how you do it. So you can divide by 100 here. Okay, already the g and the g can cancel here, so this can cancel, this can cancel. So you're going to remain with 35 as to 8. Right, can we reduce this? There's no number that is common. We can't reduce by any number here, so that is it in the simplest form. So that's how you work out a ratio, guys, just like that, and done. On number B, we are given that there's a farmer here who harvested in 2016. He had to harvest 4,5 tons of maize, and this was actually a 20% increase from what he harvested in 2015. So what is then going to be the number of tons that he harvested in 2015 if this was due to 20% increase, which is more in 2015? Okay, this is what happened. In 2015, he had harvested something that we do not know. So that is where he started, like the reference is 2015, which is 2015. That is your reference. So you're going to take your reference to be at 100%, to say that at 100%, which is in 2015, we do not know what this guy obtained in terms of the number of tons. But what we know is that in 2016, the harvest that he had, it has to increase by 20% from 100%. So which means we are now at 120%, because this is an increase. So you add 20%, which means you are now at 120%, which gave him, or this farmer, the total harvest of 4,5 tons in 2016. He had 4,5 tons, that is in 2016. So what was his harvest in 2015 when he was at 100%? That is where we are taking as a reference. We are taking 100% as our reference. Then an increase you add. If it was a decrease, you subtract. So definitely we want to find this 100. So it's 100 over what we are given, 120 times 4,5. Whether this is more or less, that one does not matter. What you want is what you write on top. So 100 over 120 times 4,5. So that's it, guys. So as you can see, 100 times 4,5, that's simply moving 2 commas to the right, which is 450. So it's going to be 450 over 120. So we can reduce this 0 and the 0 there. So which number can we use? 3. 3 into 12, that is 4. 3 here, that is 1, remainder 1, into 15, that is 5. 4 into 15, we have got into 12, which is actually 3 times into 12. Then you're going to have a remainder of 15. minus 12, 15 minus 12, which is going to give us 3. So that will be 30 there. So definitely I now have a comma. 4 into 30, which is going to be into 28, that is 7 times, and 30 minus 28, which is a remainder of 2 into 20, that is 5. So that's it. So that is what you obtained in 2015. He had 3,75 tons. Then in 2016 it was an increase. So there are so many ways, guys, so many ways. I think you can apply any method, but make sure that you are going to have the same answer like the one that we have. So I'm just trying bring some of the methods that you were not used to them, so that it's not like wise to repeat something that you already know. All right, solve the inequality. We are given the inequality to solve on A. Let's just put this way. This is 14a, which is 4 minus 5x is less than 2x plus 8. So how can we solve this inequality? We can transpose depending with how you want to simplify it. So in this case, if you are to transpose this term here, it is going to be minus 5x. 2x to the side is going to be minus 2x is less than, already we are given 8 here. Then we transpose this 4 to this side is going to be minus 4. Take note, when you transpose like this, the sign does not change. You just write as it is, okay? Minus 5 minus 2, which is minus 7x, is less than 8 minus 4, which is 4 in this case. All right. So take note, what you are solving, you want to solve for x. All right. So this is what you're going to do. Divide by negative 7 by negative 7. The moment you divide by this negative, take note, guys, that I told that the moment you divide by a negative, the inequality sign reverses. It is going to change its direction. Then it's now minus 4 over 7. Remember that we can't write our answer with a negative in the denominator. You have to write it on the numerator. All right, so that's it, guys. Then from this part, we are now given to write down the smallest integer that satisfies this inequality, which is this inequality, which is the same inequality that you're given. Okay, so what you simply do, it's a continuation that you are talking about here. So we are saying that our x is greater than minus 4 over 7, which is actually a decimal. Like if we are to have it like on a number line, let's say this is where we have our 0 here. Minus 4 over 7, maybe it's on the left side, so we are going to have it somewhere here, and this value is going that. So here we are given that at this point our values are greater than, which means actually we are going this direction, where we are going to have the first number, which is 0 here, followed by 1, followed by 2, followed by 3, and so on. So which means definitely the first integer that we are going to have is 0, which is the smallest, because these numbers, they are increasing, and 0 is the least that we can get. So that is our least integer that we can have for the values of what? Of x, which are greater than minus 4 over 7. So that's what we had, and we are given on number 15 logarithms. The logarithm of a, which is equal to 3, the logarithm of b, which is equal to 7. Then you're asked to calculate log ab. So these questions, what they do is that they just want to test you. How do you apply the laws of logarithms? How do you know them actually? Like, do you know that when you are given this concept from your laws, we said the bases are the same here, and you are multiplying. So what was the law that made you to multiply the numbers like this? That was the law that we said log a plus log b. When we are adding the logarithms of the same base, in this case you are in base 10 because the base is not written. So that is how you can separate this. So we have got the value of log a here. Log a is equal to 3. So we can substitute in place of log a, we put 3. Plus in place of log b, we put 7, because it is by what? By 7. So if we add this, we are going to obtain 10. So this is the value of what? Of log ab, which is equal to 10. Just 10. Okay. Then we move on to log 1 over b. Which law are we going to apply? We are dividing, which means we were subtracting the logarithms. The logarithm of 1 minus the logarithm of b. That's the law from our laws of logarithms, remember? So logarithm of 1, where are we going to have balls? Here we do not have balls, we are given letters. This one we know. Remember I told you, as long you are in base 10, you are supposed to know from log 1 up to any log. Log 1 base 10 is 0, log 10 base 10 is 1, log 100 base 10 is 2, and so forth. So this log of 1 in base 10, that's a 0 here, minus log b. Log b, we are given that log b is equal to 7, so it's going to be 0 minus 7, and that's minus 7. So that's what you're going to have here, minus 7. So these are the laws of logarithms that they are testing you to reverse those laws of logarithm then. So for logarithm of 1 in base 10, you're supposed to know it. Okay, what about this one where we are given this is the log cube root of a? I don't know if it was cube root or it was square root, but there was a number, it was fifth root, or I don't know, but I just took it as cube root of a because it was not clear. So this one, from our laws of exponents first, cube root means to the exponent of what? A third. Just like you're given square root. If you're given square root, it means to the exponent of a half. Cube root to the exponent of third. You just raise to the exponent of 1 over the number that is inside the root sign. If it is 5, it is going to be 1 over 5. All right. Then from our laws of logarithms, there is this law that we talked about, p log m, which gives us log m to the exponent of p. So this time we are given from this way to this direction. So we are going to drop the exponent. It's going to be p log m. So here we've got a third as an exponent, so it's going to be a third log a, like that. We have to apply this until log a is clear enough so that we can clearly see this is our log a that we can substitute, because we are given this value of log a on our information. Here we are given that our log a is equal to what? Our log a is equal to 3. So you are simply substituting now in place of log a 3. So this can cancel and you've got 1. So that's our answer there. There is no log on our answer. It's just 1, just a normal number 7. Okay, so that's how they ask these questions, guys. So let's see on question number 16, which is a function. There we are given functions f of x. So let me just write it down here. F of x is equivalent to x plus 4 into 2x minus 1. Okay, so this is your f of x. So the first question is to find f of 3. So what does f of 3 mean? It simply means in place of x, substitute 3. That is what you simply mean, because this is f of x. So f of 3, simply substitute what? 3 here in place of x, f of 3. So it's going to be 3 plus 4, that is in place of x, into 2 times x. So it's going to be 2 times our x, which is 3 minus 1, like that. Okay, so let's simplify, guys. 3 plus 4, that is 7. Okay, from our bracket 3 plus 4, we are going to obtain 7. Then we move on here, expand this bracket. 2 and 3, these two must expand first. 2 times 3, which is going to give us 6 minus 1 in this case. All right, then we are going to be left with 7 times 6 minus 1, which is 5. Bracket by bracket, simply you're multiplying, so this is going to give you 35. So that's it, guys, just like that. Then b, we are asked to solve the equation. All right, let's see how you're supposed to solve this equation. That's 3m over 4 minus m over 3 is equal to 2.5. Okay, let's just convert, guys. 2.5 to improper fraction. You multiply 2 times 2, that is 4, plus 1, which is 5. So it's going to be 5 over 2. So it depends with how you want to solve this equation. Someone can clear fractions, someone can collect like terms. It depends with what you want. So as for me, I'm just going to clear fractions at once. Find the LCM of 4, 3 and 2. What is our LCM, which is what? 12. Yeah, so multiply by 12 here, by 12 here, by 12 here, each and every term. So remember, it's going to be 12 divided by what? By 4, which is 3. That is 4 into 12, that is 3. So it's 3 times 3. This is paper 1, guys. We are not going to show much working, so let's just do it at once there. 3 times 3, that is 9m. Okay, the same thing here. 3 into 12 here, that is 4. then 4 times minus m, which is minus 4m. Okay, 2 into 12 here, that is 6, then 6 times 5, which is 13. So we have cleared fractions. Now you can collect like terms. 9m minus 4m, which is going to be 5m, is equal to 30. Divide by 5 definitely. Both sides, our m is going to be 6. 30 divided by 5. I think this one is clear. So maybe you decided maybe to work it either way. Maybe you wanted to first combine these two. Yes, it was another option that you could have done, where you just find the LCM of these two numbers, which is LCM of 4 and 3, which is 12. You want to combine, so it's going to be 12 divided by 4, which is 3. Whatever you get, you multiply to the numerator. So 12 divided by 4, which is 3, times 3, which is 9m, minus 12 divided by 3, which is 4. Whatever you get, you multiply there. So it's going to be 4m, which is equal to 5 over 2. All right. So still, we are back here. 9 minus 4, which is going to give us 5m over 12 in this case, which is going to give us 5 over 2. So what are you going to do? Cross multiply definitely to remove the fraction. So it's 2 times 5, which is 10m, which is equal to 12 times 5, which is 60 in this case. Okay, so by 10 m is going to give us 6. So that's what we have. Or at this stage, when you've got 5m over 12 is equal to 5 over 2 like this, you can even cancel this 5 and this 5. All right, still it's one and the same thing. And to find m, you can multiply by 12 here, by 12 here. So this can cancel. M is equal to 12 over 2, which is 6. So guys, mathematics, we can talk of 100 different methods of simplifying these things, but you just need to know a method that you are best at, and you utilize that one. Because there are so many ways, guys, that you can use. Okay, anyways, on number 17, we are given two vectors, vector p and vector q, and we're asked to express p minus q in terms of x. We are simply subtracting p minus q. Simply means vector p, which is 0 minus 3, you substitute in place of p, minus vector q, which is x1. So this is x and 1. Okay, so that is what you have. So you can subtract 0 minus x, just like 0 minus 1, it's minus 1. 0 minus 10, it's minus 10. So definitely 0 minus x is going to give us minus x. All right, minus 3 minus 1, so you're having minus 3 minus 1, which is minus 4. You simply add the numbers, 3 plus 1, which is 4, then you take the common sign. So that's it, guys. In terms of x means your answer must have x. Your answer is supposed to be having x. That is what it means when it's written in terms of x. All right, anyways, let's move on to another part where we are now given the possible values of x now, that the modulus, so take note, when you are given these lines, is the modulus or the magnitude or the length is equal to 5. So this is your p minus q, this one. Remember, this is your p minus q. We obtained this as a single vector. So what we are going to simply do is to find its modulus in terms of what? In terms of x. And we know that modulus, you square x and you square y. Okay, so it's going to be minus x squared plus minus 4 squared, which is equal to this modulus that we are talking about of p minus q. We are already given that it is equal to what? It is equal to 5. So by doing this, we have formulated an equation where we have to solve for x. So how can we remove this square root? You have to square both sides. Okay, the moment you square both sides, you are simply removing this square root, so which means you're going to be left with minus x squared, which is x squared. Remember, negative squared becomes a positive. Minus 4 squared simply means minus 4 times minus 4, which is 16, which is equal to 5 squared, which is 25. So take note, the square root has been removed by this square, but here you have to square 5 squared is what? 25. Definitely collect like terms. X squared is equal to 25 minus 16. 25 minus 16, guys, this is 9, right? So introduce the square root because there is a square now, so you have to introduce square root both sides, and square root of 9 is going to give us plus or minus 3. So definitely we shall have our x as 3 or another x which is minus 3. These are the possible values of x that you are having, plus or minus 3. So guys, as you can see, it's a play around type of a question where you have to apply the idea of what you know and use that. State the special name of a given to a regular polygon with 4 sides. So a regular polygon, remember, is the number of the sides are equal, so all 4 sides are equal. And what type of a shape with all 4 sides which are equal and all 4 angles which are equal? That's a square, because on a square, remember, all sides they are equal and the angles they are equal. You'll be having 90 90 90 90. A rhombus is not going to work. Why? Because the angles they are not equal. Yes, the sides they are equal throughout, but the angles are not equal, of which a regular polygon, the sides must be equal, the angles must be equal. So the one that is going to qualify is a square. All right, so here's a square. The angles of a hexagon are, so these are the angles of a hexagon that we are given. Then you're asked to find the value of x. So what can we do? These are the interior angles of a hexagon. So we simply need to know what is that sum of the interior angles of a regular of a hexagon, whether it's regular or it's not. We just need to know the sum so that we can equate that to the sum. Okay, so that's it, guys. So let us find the sum. How do you find the sum of interior angles of any polygon? It's n minus 2 times 180. That is the sum of what? Interior angles. So the sum of interior angles is given by n minus 2, and this is a hexagon which has got 6 sides. So in place of n, substitute 6 minus 2, that is 4 times 180. So if you multiply properly, guys, this must give you 720 degrees. So which means this polygon is going to give us 720 degrees as the interior angles. So what you are going to do, these are the interior angles that you are given, so you are going to add them and equate to 720. So you're going to add, guys, add these numbers, 115 plus 89. So it's 115 plus 89 plus this x is 2 4, so they are 4 plus x plus x plus x plus x. We must obtain 720 degrees, which is the sum. So these two, if we add them properly, we're going to obtain 204 plus x plus x plus x. This is 1 1 1, which is going to give us 4x is equal to 720. So definitely, guys, how can you find x? Transpose 204 to that side, which means you are going to subtract 204 from 720, which is going to give us 516. So divide by 4 by 4. That's x is equal to 4 into 5, that is 1. Remainder 1. 4 into 10, that is into 8, that is 2. Remainder 3 into 36, which is 9. So that's our x, which is 129 degrees. So this x, as you are seeing it, we are seeing 129 degrees for a hexagon. All right, so that's what we had. Then on this question we are given on number 19, in the diagram we are given triangle ABC, where we have got, which is right angled at B, and we're given the size 12 centimeters and BCA, which is 45 degrees. So from this information we are given sine 45 is square root of 2 over 2. So they are saying from this 45 here, because this triangle is supposed to, if you are to work with this triangle like this, this is 45, this is 45 like this. So when we write this square root of 2 over 2, this side is actually 1 1, and this is referred to as square root of 2. So you're supposed to know this principle. So sine 45 is simply from opposite over hypotenuse, which gave us 1 over square root of 2. And we know that from our laws of sets, you're not allowed to put the square root in the denominator, so you multiply by square root of 2 over square root of 2. So 1 times square root of 2, which gives us square root of 2 over square root of 2 times square root of 2, which is 2. So that is where these values came from. You do the same for cos. As you can see, these two, they are equal. So if you find cos 45, it's going to be adjacent over hypotenuse, which is 1 over square root of 2. So definitely they are going to be of same answer. All right, anyways, let us see what you're given. The question here is to calculate BC, leave your answer in set form. So this is BC, this side here. So according to this angle here, this is your adjacent, because you've got 90 degrees here. So you've got adjacent and you've got the hypotenuse. So which ratio are you going to use that has got adjacent and hypotenuse at the same time from your soccer tower, or those ones who use this one, or those ones who use soccer tower? All right, so from our soccer tower here, we need where we have got adjacent and hypotenuse at the same time, which is this cos. So cos of theta is equal to adjacent over the hypotenuse, which is cos 45 degrees in this case. That is our theta here, this angle. It's adjacent, which is your BC, the one that you want to calculate, over the hypotenuse, which is 12. So it's going to be BC over 12. So definitely I want to find BC. So what am I going to do? Cross multiply both the same as over 1. So 1 times BC, that is BC is equal to 12 cos 45 degrees. Okay, so if we have got 12 cos 45 degrees, therefore we can substitute, that is 12 times cos 45 degrees, of which we are given this cos 45 degrees as square root of 2 over 2. So you're going to substitute square root of 2 over 2. So that's it, guys. Just like that, we have to substitute. So 2 into 12, that is 6. So you're going to have 6 square root of 2, that is your BC. These were centimeters. Yeah, this is centimeters. So that is what you're going to have for BC in set form. In set form means your answer is going to remain with the square root. Okay, with the square root. This, that is in set form, your answer is going to have this square root. That is what it actually means. Okay, so if you are given this typical question, guys, it's a matter of play around the question. Okay, so you've got this BC, then now they want you to calculate sine ACD, leaving your answer in set form again. This is sine ACD, this is ACD. Take note, guys, this is sine 45, and this whatever angle, whether we know this angle or we do not know, actually is going to give us 145. But whether we know this angle or not, this is an obtuse angle to this acute angle. And remember, guys, what I told you between the obtuse and the acute angle, that for sine they have the same values. So sine of ACD and sine 45, they are equal. So this one, it is equivalent to sine 45 degrees, which is equal to what? Which is equal to square root of 2 over 2. Remember, we are given a square root of 2 over 2, so this one does not change. Okay, then what about tan ACD? Okay, this is tan here, tan ACD. So tan now, it is going to be a negative. It is only sine which is a positive when it is obtuse, but cos and tan, they are negative. So which means we are saying that tan ACD is going to be the negative of the acute angle which is inside. So it's negative of this angle here. So it's negative tan 45 degrees. Okay, so tan 45, where are we going to obtain it? Okay, take note, this is a 9, this is an isosceles triangle, this is 45. So which means this side and this side, they are equal. And we know that tan is opposite over what? Over adjacent. We calculated BC, whatever that we obtained, whether the sides, but the moment we say opposite over adjacent, they're equal. Even from this one, opposite over adjacent is going to give us 1 over 1, because these two sides, they are equal. So whether this is 6 square root of 2, 6 square root of 2, these two sides, they are equal. So you're going to obtain 1. So tan 45 is equal to 1. So you're going to obtain minus 1, because tan 45 is 1. So our answer there is going to be minus 1. So take note, if it was cos ACD, it was going to be, we are not asked this one, but let's say they asked cos ACD, it was going to be minus cos 45 degrees. Why? it's an obtuse angle of 45 degrees. So it's minus. It's only sign which remains a positive. So which means this one was going to be negative. Cos 45, we are already given. Cos 45 is what? Square root of 2 over 2. So it's going to be minus square root of 2 over 2. We are already given that one. So do you see how they ask these questions? It's very, very important that you understand basics of trigonometry in mathematics. Okay, even though it's not like explained in a better way, but please make sure that you work on trigonometry. It's will help you a lot to attempt such typical questions. Okay, anyways, let's see what we have on this part, which is on number 20. You're given a table and you're asked to write down the interval which contains the modal height. So modal height is the height with the highest frequency, so which is 6 to 8. So this is your modal height. H is greater than 6 but less than or equal to 8. You write as it is. You take the one with the highest frequency. This is the highest number, 16, but the class is this one. Okay, the median height. So the median height, you find half of the distribution so that you can actually find it. So this is item 1. So median height, you're going to find half of the distribution. The distribution means n plus 1, which is n is the total frequency, the total number of trees, which is 500 trees in a school orchard, which is, if you add this, you're going to obtain 50. So it's going to be half of 50 plus 1, and half of 50 plus 1 is actually 51. So it's going to be half of what? 51, and 2 into 5, that is 2, and 1 into 11, which is 5 comma 1 here, which is 5, 25 comma 5, somewhere there. So 25 or 27, 2 into this is 51. So you just divide properly, guys, but this one is going to give us 2 remainder 1. And so where we are going to have this value of 20 comma 5, that is where our answer is going to be, where we are going to obtain this. So you add 16 plus 12 plus 16, yes, actually 28, which means we have already exceeded this number. So it means it's going to be in this region, which is 6 to 8. Or you can add from this side, 10 plus 12, that is 22. As you can see, we are still less than 25, so which means we are not here, we are not in the range, because this is less than. But if you add 16, it's going to exceed that value, so which means this value of 22,5 is occurring in this region of 6 to 8. All right, so our median height is going to be h is greater than 6 less or equal to 8, just like what we did on the median, on the model. Then calculate an estimate of the mean height of the trees. Remember, estimate of the mean is class center times frequency. You add class center times frequency, class center times frequency throughout. So how do you find the class center? You add the lower class and the upper class, then you divide by 2. So it's 2 plus 6, which is going to give us 8. Then 8 divided by 2, it's 4. That is 4. So which means our class center here is 4. Or even by sight, you can even see that the number that is in between 2 and 6 is what? It's 4. So that is 4 times the frequency, which is 12, plus the number that is in between 6 and 8. Definitely it's 7. So you can add 6 plus 8 divided by 2. So 6 plus 8, it's 14 divided by 2, which is 7. Then 7 times 16. So it's center, class center times frequency. So it's 7 times 16. Plus, you move on 8 to 10. As you can see, the class that is in between the number is 9. So it's 9 times 12. So you add there, guys, and you divide. I think it's going to be easier. You move on to 10 and 12, which is 11 times 10. Okay, everything over the total frequency, and your total frequency is 50. So now someone has to multiply 4 times 12, which is 48. Yeah, that is 48. 16 times 7, that is 112. Multiply properly. Then 9 times 12, which is going to give us 108. 110 times 11, just a 0 there, which is 110. Everything over 50. So adding properly, guys, we are going to obtain 378 if we add properly over 50. So that's it. And we're going to divide. So you can divide by 5. Or let's just choose 5 first. I want you to see, because we want to target to use 10. So you can target 5 by 5 here. It is going to be 10 over by 5 into 37, which is going to be into 35, which is actually 7 times remainder 2. All right, 5 into 28, which is 5 into 25. That is 28 minus 25, which is a remainder of what? Of 3. So it's going to be comma. Then 5 into 30, which is 6. So you're going to have 75,6 over 10. Now we can just move 1 comma back to the left, which is 7,56. So guys, like I said, paper 1, you do not have calculator, so you have to be very, very careful how you divide, unless you know that you are going to finish that paper, because it's a matter of finishing also the paper. So sometimes you have to be very careful. Okay, for number 21, we are given the probabilities of Temba winning or scoring in a match, and also Alan scoring in the same match. The one for Temba, maybe if we can write it down, it's going to help us. So there are 2 guys here, which is Temba and Alan. All right, so they are saying that Temba here, for him to score, it's 1 over 3 in a match. Okay, so for him to score, it's 1 over 3. So what about not scoring? What about the probability of not scoring? So there are 3 chances of scoring, but like everything is, there's a possibility of 3, but he can only score once out of 3, which means he has got 2 chances of losing. So it's 3 minus 1, which is 2 over 3. All right, we move on to Alan. He has got 3 over 4 chances of what? Of scoring. 3 out of 4 chances of scoring. So what about the ones of not scoring? What is going to be the probability of not scoring? So out of 4 chances, you managed to score 3 times, so which means only 1 out of 4 was a fail. So that is how you take, or you simply say, if you have got this one as 1 over 3, not scoring is going to be 1 minus 1 over 3. This one is going to be 1 minus 3 over 4. You subtract using your fractions, still you are going to obtain the same answers. So the question now is, calculate the probability that in the same match, both guys, they are going to score, which means you're talking of a condition where Temba is going to score and Alan is going to score. And we know that when you are given probability and it's both, whenever you are given both and, which means you're going to multiply the 2 outcomes. So you're talking about Temba scoring, which is 1 over 3, times the probability of Alan scoring, which is 3 over 4. That is what they mean. Okay, so simple like that, which is going to 1 and 1, which is 1 over 4. That is our probability there. All right, we move on to B. Now they're saying neither of them scores, which means none of these guys, no one is going to score. No one is going to score, which means we are talking of condition here. These are the guys that we are talking of Temba not scoring and also Alan not scoring. Okay, so that is going to be 2 over 3 of not scoring for this one, and this one is going to be 1 over 4. So what are we going to have, which is, you can reduce by 2, that is 2 here, which is 1 over 6. So that is what you're going to have. No one had to score on this condition here. All of them, they scored. Here no one scored. All right, don't confuse this question with this one, which is now asking us to calculate a condition when only one of them scores. Only one of them scores means to this is what you're talking about. When one scores, which means when Temba is going to score at this moment, Alan at that moment is not scoring. Temba is scoring, Alan is not scoring. All right, when Alan is going to score, Temba is not scoring. That is the condition that they're talking about. So you're going to take Temba scoring versus Alan not supposed. They're saying one is supposed to score. So if Temba scores, Alan is not. We move on to this condition. If Alan is going to score, then Temba is not going to score. So these are the two outcomes that can happen. So you combine them together. So it's going to be, this is item C. So it's going to be the probability of this Alan scoring versus in Temba scoring versus Alan scoring, which is 1/3 times 1/4. Because it's one who is going to score. So at this moment, Temba had to score, but Alan is not scoring. Okay. Plus, we combine another combination where Alan now is the one that is scoring with 3/4. But at that moment, when he's supposed to score, Temba is not supposed. This one is scoring. Temba is not supposed to with 2/3. So it's going to be 2/3. So as you see, if you can list your information like this, it's easier for you to just take your information. So now you can combine these 1 times 1, which is 1/3 times 4, which is 12 plus. Already here I have maintained a denominator of 12. So try to maintain, yes, you can reduce this, but try to maintain the denominator of 12 so that you can easily add. So 4 times 3, which is 12. 3 times 2, which is 6. Now you can add properly. Why? The denominators are the same. Don't reduce these numbers because you want to add. So if you reduce now, you're going to beg to find the LCM. No, just leave it over 12. Your LCM is already there, which is 12. Remember, when the denominators are the same like that, you just add 1 plus 6, which is 7. So you're going to have 7/12. And this one can't be reduced. So you just leave it like that. So these are some of the things that you're supposed to avoid in exam to make a lot of working in the paper there. So that's number 21 actually. Yeah, that's number 21, everything. So let's see. On number 22, we are given in this case, okay, the first question on 22A is to convert a speed of 12 meters per second to a speed in kilometers per hour. Okay, remember when you're talking of speed, I gave you this concept that in a meter, we can actually use that in a meter per second, we have got 3,6 kilometers per hour. So in this case, we want to convert 12 meters per second. So we've got 12 meters per second is going to give us what we do not know. So whatever that you want is 12/1 times 3,6. It's now in kilometers per hour. So 12 times 3,6, guys, this one you just multiply properly. It must, remember, you neglect like the 36 times 12. Multiply 36 times 12. It must give us something like 4320 there. Then 1 decimal, 3432. Okay, then you've got 1 decimal place, which is going to be 43,2 in kilometers per hour. So make sure that you multiply properly, guys. 36 times 12, you obtain your answer then on decimal place. Okay, on number B, the graph shows the motion of an athlete running on level ground at a constant speed, 12 meters per second for 5 seconds. So this is 12 meters per second for these 5 seconds. The athlete then retards. To retard is to reduce speed, that is deceleration, uniformly to rest after a further 3 seconds here in between 8 minus 5, that is 3 seconds. All right, then the question is to calculate the total distance traveled in 8 seconds. So guys, this is a trapezium. You can use the area of a trapezium at once because distance is equal to area, or you can use the area of a rectangle plus area of a triangle. Here still it's one and the same thing. You must obtain the same thing. So distance, remember, is area under the graph. So that is our B item 1. Sorry, that is B item 1. So distance is equivalent to area under the graph, guys. All right, so which is we can put this trapezium. Remember, area of a trapezium is half sum of parallel sides times the perpendicular height, which is half of the sides which are parallel. Which sides are we talking about? We are referring of these sides here. These are the sides which are parallel. So we're talking of from this point it's 5, from this point to this point it means also we've got 5 units here, so it's 5, and this is the perpendicular height, which is 12. So that is what we have. So we're going to add 5 plus 8, so it's going to be 5 plus 8 times the perpendicular height, which is 12. Just like that, you have got your area. So it's going to be half of 5 plus 8, expand the bracket, which is 5 plus 8, that is 13 times 12. So half of this is 6, and 13 times 6 is going to give us what? 78 meters. So that's our distance. Remember, is distance in meters, or you can use area of a rectangle. So our distance could have been area of a rectangle, which is length times width. In this case, so it's going to be 12 times 5. That's 12 times 5 from your length times width, plus area of a triangle, which is half base times perpendicular height. So it's going to be half times the base from 5 to 8. So it's 8 minus 5, which is 3. Okay, so we've got 3 times the height, which is this one, 12. Okay, so that's it. Combine there, you're going to obtain your answer, which is 60 here. Then half of 12 is 6 times 3, which is 18. Yeah, so if you add, still you're going to obtain the same thing, which is 78 meters. Yes, you are calculating area, but this is distance. So you are supposed to use the units of distance, not the units of what? Not the units of area, to say square centimeters or this. No, you're supposed to use the ones that you're given there. All right, so that's it, guys. Let's see another question, which is on number 23, where we are given circle geometry, guys. As you can see, these questions on circle geometry, they just repeat one in the same thing. You're given a circle, angle at the center. So remember, guys, angle at the center is twice angle at the circumference. So definitely this angle must give us something like 30 degrees. Radius is equal, so if this is 7, this is also 7, which means you can find this angle, also you can find this angle, so many ways. Okay, anyways, we are given to calculate ACB, that is ACB. So that's it. Angle at the center is twice angle at the circumference, so at the circumference you divide, so that is 30. So this one is already 30 there. OAB, so we said this angle and this angle here, from the concept of a radius, they are equal. So you're going to simply subtract from what? 180 minus 60, which is 120 degrees. Then you divide by 2 because they are equal. So this is 60 degrees, this is 60 degrees. So as you can see, this intends to be now an equilateral triangle, because this is already 60, 60, so which means this is 7, this is 7, everything is now equal, just like that. Okay, anyways, calculate the length of the minor arc, which is AB. So the length of the minor arc, this is the length of arc AB, this one. What is going to be the length of the arc? Okay, so take note, guys, from your notes there. I told you that the length of arc is equivalent to theta over 360 times the circumference of a circle, which is 2 pi r. So it's theta over 360 times the circumference of a circle. So that means the length of arc is going to be theta, that is the angle which is subtended by the what? By this chord, which is 60 degrees. So that's 60 over 360 times 2 times pi. Take note, you use the given pi. The given pi is to be used as 22 over 7 times the radius in this case, and we are given that the radius is 7 centimeters. All right, so that's it, guys. Play around with your numbers there. I think you can obtain something better. 6 and 6, that's 1. 6 here, which is 6. Yeah, we can reduce 2 here, that's 1. 2 here, which is 3. So that's what we are only remaining with. So we're going to be left with 22 over 3, if I'm not mistaken there. So can we reduce this? We can actually reduce this, guys. We can actually reduce this part, which is going to give us 3 into 22, which is going to be 7 and a third, or 7,333 if you want, 7,333, guys, but just leave which is centimeters there. Then I'm seeing something that we did not see, or we did not review here. I don't know. Okay, I will just talk about it, that there's a question that we left here. Okay, anyways, it's fine. I'm wondering. Okay, then the area of the sector A or B, the area, simply same formula, but now you're going to multiply to the area, now to the area of a circle. So area of a sector is just going to be theta over 360 times area of a circle, which is pi r squared. That's what you need to know. So as you can see, it's just a matter of substituting. Theta is 60 degrees. It's not going to change. 60 over 360 times pi, 22 over 7 times r squared, which is 7 squared. So 7 squared simply means 7 times 7, or you can write it as 7 squared, which is 49. It's just one and the same thing. So you have to reduce just like what we did previously. What's happening? This mark. Okay, 7 and 7. This one we reduced and we got 1 over 6. Then we reduced this one, we got by 2. That was 3 by 2. This is 11. So now we can't like do anything. We have to just multiply 7 times 11 times 7, which is 77 over 3. So that's it, guys. 77 over 3. This is a square centimeters, or you can put it as improper, which is going to give you 25 and 2/3 if you do properly, but you can even leave it like that. Okay, so that's it, guys. Like I said, guys, there's this part that we just left here, which was on the acceleration of the athlete in the last 3 seconds. This is the last 3 seconds. Remember, this is your 5 and this is 8. You see why I'm not writing, like, you see now it's dead like that. Okay, anyways, this is what we are having our last 3 seconds, and the acceleration is simply the rate of change of velocity over the rate of change of time. So that's from here, our final velocity minus initial velocity, which is 8, which is 0 here because it's now at rest. Our velocity is 0, so it's 0 minus the initial velocity. It started to retard from this point, which is at 12 meters per second, over the change in time in between 8 and 5. We are going to have 8 minus 5, which is 3. So we're going to have minus 12 over 3, which is going to give us minus 4 meters per square second. So as you can see, it's a deceleration because we are retarding. So which means definitely if we are talking of acceleration, it is going to carry a negative value. That's it. So I think that's it. Then this 22, the one that we had, I think every part is now there. Let's see another part. Oh, we still have some questions here, guys, to follow. Okay, there we are given information on the universal set from 1 up to 9. Then R, S, M, or all those sets. So whether you are given this, but you just need to find those elements, whether you're asked to find them or not. Okay, so you just need to find these elements, guys. On number 24, remember the universal set, guys, take note, is equivalent. Don't mind how I write this thing, guys. It's 1 up to 9. So it's 1, 2, 3, 4, 5, 6, up to 9. I think, yeah, that's it. Up to 9, everything is there. So make sure that all these numbers, they are there. So P is a set of prime numbers. So let's just list our sets P prime numbers, which is exactly divisible by what? 1 and itself. You're talking of 2, 3, 5, and 7, which are exactly divisible by 1 and itself. So you list the numbers from what? From this set that you're given. This is your universal set, which is the mother set of all the sets. Then you've got a set S, which is perfect square numbers. So you're talking of perfect square numbers, which is 1. Those 4 and 9, 1, 4, and 9. These are the perfect squares, 1, 4, and 9. The ones that are, when you determine its square root, you're going to obtain a whole number. That's a perfect square. Then let's move on to M, which is of multiples, not multiples of 3, which means we're talking of 3, 6, 9, 12. So we're going to take 3, 6, 9 up to what is in the set. We can't take 12 because it's out of the universal set, because the universal set is your mother set. Anyways, the first question is to list all the elements in P. So already we have listed elements in P. This is our elements in P. Then on B, write down number of elements in P intersection S intersection M. So before we talk about those number of elements, what do we have in these sets? P intersection S intersection M. What do we have on the intersection of these sets? What do we have on the intersection means what is common throughout. Do we have anything that is common throughout here? So cross-checking everything, guys. Let's cross-check. Do we have anything common? We do not have. 3 is not. We do not have anything. So there is nothing. We are living like an empty set. There is nothing. So which means how many elements are there? That's a 0. There is nothing. We do not have anything that is on the intersection of all the 3 sets. We do not have. So that's a 0 there. All right, then we are now asked to represent or to copy the Venn diagram complete. So you just have to complete there. So let me just put in pencil here because now if I use this, it's going to affect the other page. So this is what is, as you can see, this shows that there is no intersection of 3 sets, but there is intersection of P and M. Between P and M, P and M, we've got something common between these two, which is 3, only 3. Okay, that is common. So between P and M, we've got 3. So which means we can write what is remaining in P, because P is now free here. So what is remaining in P, if you take these 3, you're going to remain with 2, 5, and 7. 2, 5, and 7. All right, you move on to M and S. There's an intersection between S and M. What do we have? We have got 9 in this case. So if we put 9 on the intersection, it means S is free here. So you can write what is remaining in S. We are remaining with 1 and 4. So this is 1 and 4. Then M is now free. So you can write what is remaining in M after using 3 and 9 in this M. What is going to remain? We have used 3 and 9. So we're going to remain with 6. So 6 is going to be in between here. Then we check all these elements. Are there any elements that are remaining which are in the mother set? Those are the ones that you're going to write outside of this, which is we check. We are moving from 1 up to 9. So we've got 1, 2, 3, 4, 5, 6, 7, 8 is not here, 9 is there. So 8, you write it outside of the sets, just like that. So that's what you have on number 24. And on number 25, you're now given transformation. The graph shows triangle X and Y. So this is triangle X here, and this is triangle Y. So this is X and this is Y. All right. Triangle Y is the image of triangle X under a certain transformation, single transformation. Then you're asked to describe that transformation. So definitely for you to describe transformation, guys, if you are to cross-check the object and the image, these are isometries. They are the same. So you can join corresponding elements. All right. So let's join corresponding elements. Okay, this point and this point, they can be joined together. This point and this point, you join them together. Those are your corresponding points. All right. So by joining these, what are we producing here? We are having lines which are parallel. As you can see, these lines can never meet. So these lines, they are parallel, as we can see. Then we have to check their distance. Are they having the same distance throughout? So if we are to measure here, you're going to see that there is same distance throughout. There is same distance throughout. Even by side, you can see that the distance from this point is the same throughout. Or you can use your divider. It's only that I don't know where I put this thing, but you can even put a divider to measure those two, to just cross check if they are equal. So these are equal. So which transformation does that? Which transformation which produces parallel lines of equal length from our isometries? Because if you're talking of isometries, you're talking of translation, you're talking of reflection, we are referring to rotation. These are the 3 isometries. So which one is going to qualify? So definitely is translation. Reflection is not going to qualify. Why? Because we said on reflection the lines are going to be parallel, yes, but they are going to have an equal length. But these ones, they are having equal length. Rotation definitely is out because we do not have parallel lines in rotation. Rotation, the points intersect when they are joined. If we join this point to that point, the lines intersect. So rotation is totally out. So we are left with translation only. So this one, it is a translation. It is a translation. So definitely whenever you're working with the translation, you need the translation vector, where we know that translation vector is going to be image minus object. Okay, so remember, translation vector is equal to image minus object. So what you just do is you take corresponding points on the image. Remember, we are given that we triangle y is the image, so this is the image. So you take from this image, from y here, so this point corresponds to this point. Okay, so on the image, this point here as a point, it's minus 2x, here it's minus 2, y is 4, so this is minus 2, 4, but you have to write it as a vector now, like as a column vector, which is minus 2, 4, like this. As a point is supposed to be minus 2, 4, like this, but you write it like this now, minus 2, 4 as a vector. So that's your image point, minus 2, 4. So this point, you must subtract the corresponding point on the object, which is this one. These 2 points, they correspond. So this point, x is 4 and y is 1, so it's 4, 1. So that's it, guys. That's your translation vector. Minus 2 minus 4 from your vectors, that's minus 6. 4 minus 1, which is 3. So that's what you're going to have as your translation vector. So you can even prove another point like this one. This point here, this point, it corresponds with this point. Okay, so this is your image y. So this is minus 4, 8. So it's minus 4, 8. So it's going to be minus 4, 8 as a vector. Minus, you take the corresponding point on the object, which is 2. This is 2, 5, in between 4 and 6. So it's 2, 5. So that is 2, 5. Okay, so you can subtract, which is minus 6, minus 4 minus 2, which is minus 6, 8 minus 5, which is 3. So as you can see, you're obtaining the same answer. So I want you to prove the last one, this one, which is this point and this point, this one at 0, 8, and this one at 6, 5. So just prove if you're going to obtain the same answer. So our translation vector is minus 6, 3. That's our translation vector. So we are done. Then on B, we are given that triangle Z is the image of X under an enlargement scale factor 2 and the center 0, 0. State the matrix that represents the enlargement. All right, take note that the matrix for enlargement is represented by K0 Cook from K0, 0, 0. Okay, remember from those matrices I told you can take them Cook, K0, 0, you can take them that way. So this K is your scale factor. This is not the answer, guys. When we write it like this, it's wrong. K must be the scale factor, which is your scale factor is what? Is 2. So put in 2 in place of K. So this is going to be 2, 0, 0, 2. So that is the matrix for enlargement, Cook. So in place of K, that's your scale factor. So this matrix, I told you, it only operates when the center is 0, 0, and truly our center is 0, 0, so it's perfect. So draw and label triangle Z now, which is on the other part. And for us to draw, yes, we can apply the concept of enlargement. You just enlarge your triangle X here direct, or you can use this concept. Remember, guys, what I told you when you are given a matrix, to say that to find the image, matrix times object must give us the image, provided that the center is 0, 0. So the matrix is there. We said our matrix is 2, 0, 0, 2. Remember the matrix that we obtained for enlargement, times the coordinates of the object. So what you're going to do is to multiply to the coordinates of the object. So you just take any order. So this one is 4, 1 as a matrix like that, 4, 1. Okay, I'm going to take another one, this one, which is 2, 5, All right, move on to this one, which is 6 5. All right, that's it. So matrix times object is going to give us the image, so it's row by column 2 times 4, which is 8. So guys, you're multiplying by 0 here, so there's no effect. 2 times 2, you move on, that's 4. 2 times 2, that's 4. 0 times 5, you're going to add 0 here, which is not going to change anything. 2 times 6, which is 12, guys, by 0, nothing is going to change. You move on to 0 times 4, that is 0 plus 2 times 1, which is 2. 0 times 2, that is 0 plus 2 times 5, which is 10. The same thing here, which is 10. So these are the coordinates that you're going to locate on your graph: 8 2, 4 10, and 12 10. So you must locate these points, mark them, then you can draw your image. So what I'm simply saying is that we have to locate these points. I'm going to start with this one, 8 2. So this is our 8 2 here, so it's going to be here. That is our 8 2, this point. All right, when x is 8, y is 2, that's 8 2. All right, then we've got 4 10. When x is 4, y is 10, that is 4 10. At this point you mark that point, then you move on to another one, which is 12 10. So 12 is the last point, this one, and the 10, so it's 12 versus 10 at this point here. All right, so that's it. So mark your points properly, then with these points you are going to join. So enlargement also, this one, a scale factor is a positive number, so definitely you are supposed to obtain a bigger image, which opposes to that one that I said, when it is a condition that the scale factor is a fraction, there you are going to obtain what? You are going to obtain the image being smaller than the object, even though it's enlargement, but because of a scale factor which is a fraction, it is going to be smaller than. But this one, because our scale factor, it's a whole number, that's why the image is going to be bigger as usual, as we expect to have. So as you can see, guys, this one actually shows that actually enlargement occurred here. So that was it, guys, on this question paper, which was actually written in November 2018, guys. Paper 1 having a total of 100 marks. So I don't know how you see, or how you what you can say about these typical questions. The time frame that you have, 2 hours 30 minutes to answer these 100 marks, and also the mark allocation, the marks and the workings that you do, and the marks, do they correspond? Let us know, guys, so that we can at least talk about it, so that we know if these things are actually in correspondence with what we are expecting, or they are not. So that's it, guys, from us on African Motives. Till we meet again.